Okay, the main topic of this section here is what we call extrema. It's a Latin word meaning extremes. Like minimum, the plural is minima, and maximum, the plural is maxima. Latin language does that. And a lot of mathematicians deal with Latin and Greek words because the concepts were delved into first in those two areas. What we're going to do is use calculus to find the minimum, maximum, and something called a critical point that we talked about in the previous section. And so we're going to be looking mainly at an interval of a definite x value minimum and a definite x value maximum, but the minimum maximum we'll talk about. And this has to deal with the y values. What is how high or how low does it go as we go across from lowest x to the highest x in our interval. So you see these two definitions in your book. That's what they're talking about. Okay, where C is a point between A and B in the interval, and F of C is the y value. It's the minimum when it's the lowest of all the points in terms of height, and F of C is the maximum when it's the highest point. And so we're going to call them absolute minimum, absolute maximum, because they are going to be the highest and lowest point. There are other situations where we call them relative minimum, relative maximum. Maybe you have like loops in there that are not as high as the highest and lowest points, but they are still high and low of that particular region. We're not going to get into that today. The definition of relative extrema, which we pretty much talked about. The point at which the maximum occurs is at point C. The value of y is a function of C, which is what we've defined ever since chapter 1. The main part of this discussion are the guidelines that we're going to be using for this. So I'll be referring to this a lot, so keep that handy and follow along if you're not sure why I'm going in a particular direction in the problems. Okay, but we have to first find the critical numbers in the A-B area. We need to evaluate the functions. We have to find the y for each x, a, and b. For whatever critical number we have 1, 2, 3, whatever. We have to find the x first for the critical number, and then the critical point is x, y. We evaluate the function at each endpoint. So the left side we call the left endpoint, and the right side we call the right endpoint. We have to find the x, y values for those. And then the least of these values that we have found is called the minimum, and the greatest value is the maximum. So we'll be referring to those throughout the problems. If you, at this point, you're going to need your calculator, and you need to open up the book page 169. We'll start with problem number 19. This is, I'll come back to that just a little bit, but I'm going to start with the problem at this end. For this one right here, the function is 2 times quantity 3 minus x, which I rewrote as 6 minus 2x. The interval is from -1 to +2, and we need to graph that right there. So graph y equals 6 minus 2x on your calculator. And when you do that, go to Zoom 6, and then that will give you a full negative to positive scale. And then I want you to change the x minimum on your window, so go to window on that, and put -1 for your x minimum and +2 for your x maximum. You don't need to change anything else out. And then hit enter. Also, yeah, we're going to go ahead and get that much done. Okay, so the XY, you get this nice long downward sloping curve, or long straight line actually. They call that a curve anyway. And you go in the window then, change that to -1 for your X minimum, and then +2 for your X maximum. Leave everything else the same as I said. The graph. And now you get this prolonged curve here. This is the first one I made a mistake, but I couldn't get rid of it, so this is not right. This is more correct, although it probably should stop more like that, as you see as we go through this. Okay, so first of all, there's no critical point for this, because in order to have a critical point, you have to have a slope of 0 at some point in your graph. Well, there's no 0. This is a straight line. It's going to stay -2 as long as it goes. So we don't have a critical number or a critical point. So what we are going to have then is what we call a left endpoint. Which I'm going to call LE from now on. And so that means I'm going to have to take this equation right here. F sub, and this we said here is -1. So the x value for that is -1. So F sub -1 equals 6 minus 2 times -1, which is 8. So that would be the 0.18. That is our left endpoint, and it is our maximum. As you see in the graph, it is the highest point in that interval from -1 to +2. Okay, so to find that point over here, which obviously is the right endpoint, which I'll call RE, and it's the minimum because it is the lowest point on the up or down the vertical aspect of the graph. And so we'll go back, F of 2 equals 6 minus 2 times 2, which is 2. And so this point then becomes 2, 2. That's it. That's all you have to do with that. Number 21. F of x for this is -x squared plus 3x, and the interval is from 0 to 3. I went ahead and derived this to give us -2x plus 3. Now, to get the graph for this that I have here, you again go to your y equals, and then type in -x squared plus 3. Again, hitting zoom 6, you get the standard numbers, -10 to +10 for both x and y, and you see that it's a parabola. All right? Now, the next thing you're going to do is you want to get the x minimum to be 0 and the y, or the x maximum to be +3. So you go to window, you type in 0, and then 3, and then again, leave everything else alone. Now, you're going to get that goofy looking graph when you do this. So you hit graph, and it's a really stretched out version of what you saw before. Well, why is that? Well, we just changed the scope to fit the entire line down here. These cans are only this far apart to go up, but these ones here are this far apart, so we stretched out the x's so it doesn't really look like what you had to begin with, but because we have different scales, it actually is the same thing. Now, to find the critical point, you have to set your slope equation equals 0. This is not a straight line because it's got a variable in there. So we're going to set that equals 0. I'll do this in red because it's critical. It's really important. Anyway. So move the -3 over there, get -2x equals -3, and give the x is equal to 1.5. Okay? So 1.5 is being right about there. Well, that makes sense because parabolas are symmetric. They go the same quantities in either direction, in this case downward. All right, so what is the value? Okay, that's the critical number. Now we got to find the critical point. find the critical point, we come back to this right here, and we plug in 1.5 to find the y value. So this becomes f sub 1.5 equals negative 1.5 square. Notice I did not put the negative sign in with the 1.5 because it is separated here. You're not squaring the negative, you're just squaring the x. So you got to be careful with algebra when you deal with that aspect. Plus 3 times 1.5. Punch that into your calculator, and your value becomes 2.25. So this point is 2.25. So this is your critical point, and as you notice there, that is the highest point, highest vertically speaking, of your points. And so this critical point is also your maximum, or the absolute maximum. Now to find these 2 points, you can identify, you can tell right away this is 0, 0. We can do the calculations, but it's pretty obvious that's 0, 0. And the question here is, what is that point right there? Well, you can probably tell by the critical point what it is, but just to be safe, we know that this is going to have a y value of 0. We want to find the value of x. This b0 is equal to negative x squared plus 3x. And so this becomes then, I'm going to factor out an x out of this. So x times, and I'm going to make that 3 minus x here. Instead of both equals 0 and x equals 0, which is indeed that point right there, and in this case, x equals 3. So this is indeed 3, 0. Now, these are both the lowest possible numbers or values in the interval, so these are both minimum. And this is the left end of this curve, and this is the right end of this curve. So there are your answers for number 21.